Good day and welcome back to my channel. I am Dr. K. In this video, our focus shall be on the Anova table. So how to set up your Anova table and also how to apply it in solving problem. Yes, how to apply it in solving problem. So to know whether to accept your null hypothesis or to reject it. So basically, I want you to know that the Anova table is made up of 5 columns. So we shall dig deep into it. I want you to be very attentive. Now, look at the first column. You have on it at the top, you have sources of variation, followed by another one, degree of freedom. Then the other one, you have sum of squared, that's SS. Then you have the mean squared, MS, and you also have your F calculated. So I hope you are taking notes. So those are the columns. So now also by the left hand side at the beginning, under the sources of variation, in that row, the row of the sources of variation, we have the treatment followed by error in the row, then followed by total. I want you to take note as we shall be needing all of them. So now under the that row belonging to the degree of freedom, you have t minus 1. That's for calculating your for your treatment. You also have tr minus 1, and you also have rt minus 1. So take note carefully. Then under the ss, you can see sst. So if you notice, the t there is representing treatment. So because it's in line with that, and the treatment there, you have sst. Then the same thing, sse, that's some square error, then some squared total. So that's that. So I hope you can see. So now that's how it is. So these are the formulas. So now finally, there's one formula here. SST over t minus 1 equals to, so that's A, that's B. So let's leave that. We'll still move to that. Now, F calculated equals MST over MSE. So when you get your MST over MSE, that will be your F calculated. So we go. Now let me move to the page. I'm on page 37 right now. I would like to make a comment there. Now you can see in the 5th column you have F calculated there. So after doing everything, you'll be able to find the parameters you need to calculate your F calculated. Are you getting it? Now when your F calculated is greater than F tabulated, that means you will have to reject the null hypothesis, H naught, sorry. So you have to reject it. So that's that. So it signifies that there is significant difference. So that's that. That's when F calculated is greater than F tabulated. So take note of that, because we'll still apply it in problem. So you might not really get it now, but you will still get it as we move on. Now now having done that, let me move to page 38. Page 38. So now okay. You can see the example there on page 38. Carry out Anova test. So given 3 types of treatments, A, B, and C. You can see the treatments A, B, and C with 4 replicates. Now this case we are dealing with, in this example, it is an example of one-way Anova with equal replicates. Are you getting it? So now when you're talking of let me quickly analyze some things. Okay, so they say carry out Anova test to analyze if there is any significant difference among the treatments. So take alpha equals to 0.05. that is for your level of significance, that's 0.05. So they now say carry out to test the test to analyze if there is any significant difference among them. So you can, when you go back to page 37, you discover that for you to prove that you have to find your F calculated. So, and there's F tabulated. So we are still going back to that. Now let's go. Let me quickly tell you that. So now this is well arranged on page 39. Yeah, it's well arranged on page 39 here. Now, when you're talking of the replicate, the replicate the replicate is the vertical column. Is the vertical column. That's the replicate. So you can see what they put in the first column here on page 39. They put replication that you see 1 2 3 4. Can you see? So that's why on that page you have it as r equals to 4. That's your replicate. Now for the treatments, your treatments is the horizontal column. Take note, horizontal column. So for the treatment, for the first column we have 2 2 3. So that's the treatment. You can see that we have and so the treatment is 3. If you start counting 1 2 3, counting by colon 1 2 3. So that's that. Take note of that. Yes. So now we have to now move to your capital N. Your capital N is, that's your treatment times replicate. Are you getting it? It's as if you are multiplying row by column. Are you getting? That's treatment times replicate. Don't forget that your treatment is your horizontal. So and we have total of 3 treatments. 1 2 3. You can see it there. So that's that. You have that one as 12. Then we have the grand total. We have the grand total. The grand total we are talking about here is everything was, we find the total of everything. The total of the first column is 9. Are you getting it? And the first column is 9. So when you add 2 plus 3, 5 plus 2, 7 plus 2, then you have 9. So the total of the second column is 17. When you add can you see the way it is? So the total of the third column is 10. So when you add 9 plus 17 plus 10, you have a total of 36. That's that. So that one settled. We can now go forward and make our Anova table. Yes. So I've explained some things about the Anova table, but we apply the knowledge gained from there. So now let's go to the Anova table. Okay. First thing first, to prepare your Anova table, I've already outlined the 5 that we have a total of 5 columns and we have 4 rows. Okay, should I say 3 rows? So 5 columns. Then you have your on the first column you have source of variation, treatment, error, total. Are you getting what I'm saying? So now one thing I would like you to notice that what you actually have problem with is getting your treatment and getting your total. Are you getting it? So if you can get your treatment and your total, the error is not the problem. It's actually very easy to find. Yes, the error is actually very easy to find. So let's go. So now to get your treatment, so that will be gotten as t minus 1. T minus 1. Don't forget our treatment. If you check from up here, go back to the video, our treatment is 3. So that would be t minus that will be t minus 1. That will be t minus 1. That will give you that. Now to get your total, your total will be n minus 1. So n minus 1 will give you don't forget our n is 12. Though don't forget n is treatment times replicate. So that will give you 11. So that's why don't forget I'm on page 31. So that's the essence of the 11 you are seeing here. Are you getting it? Now to get your error easily, just subtract your treatment from your total. So you can see that the error is 9 in that direction. Are you getting it? So that's that. So now you need to get your SST. That's sum squared treatment. SS small t, yes, sum squared treatment. And to get that, what you need to do is to you need the formula. It's actually not very logical. So all you have to do is square. You have to square the total of each of your column. Square them. Are you getting what I'm saying? So and divide by your replicate. So the total of each of your column, that's you have 9. Go back to page 39. You have 9 as total, you have 17 as total, square it. You have 10 as total, square it. Then divide by your replicate, which is 4. Then minus your grand total over n. Are you getting it? Over total number here. So when you do that, so g square over n, square your grand total over it, so you can see that. So finally you get your 9.5. Yes, you get your 9.5. So now sum squared total, that's SS capital T. Sum squared total, what you have to do is, for the sum square treatment, we only squared the total of each column. Are you getting it? The total of each column. Now for the sum square total, is not like that. You have to square each of the values. Under here we have 2, 3, 2, 2. So you square 2, add it to the square of 3, add it to the square of 2, add it to the square of 2 again. Then go to the second column, column B. Then you square 2 also. You add it like that. Now look at how it is done on page 40. They squared everything. So the same way, minus your g squared all over n. So I hope you are following. So when you do that, you get your total also. Now as I said earlier, your error, you don't need to be memorizing any formula for that. So just go ahead and subtract your treatment from your total. So you can see 20 minus 9.5, you get 10.5. You get 10.5. That's that. So mean square treatment, that's your MST. Now we're on the 4th column now. So mean square treatment, you get it as, so you just divide your SST by your degree of freedom. So I hope you are following me. So when you do that, what you get is 4.75. You can see how it is done there. The same way for the MS error. So there's not MS. We only have MS treatment and MS error. So when you do that, 10.5 divided by 9, you get your 1.17 here. You can see how it is now. So now when you now divide your MS treatment by your MS error, so you finally have what we call 4.06. Now so you now compare. They now said the question says you should check if there is any significant difference or not. So you now finally check, is there any significant difference or not. Now you will have to compare your F calculated. Now 4.06 you get is your F calculated. So you have to compare it with your F tabulated. So when you compare it, so now how do you get your F tabulated? You get it by your degree of freedom. Are you getting it? So that's left. Now how to find your F tabulated from degree of freedom, that's another topic entirely that we'll treat. So but basically, let me just tell you simply that you use your degree of freedom. For the degree of freedom, you use your treatment and error. Your treatment is 2 and your error is 9. Are you getting it? So now for the under the F table, for the level of significance of 0.05, so all you need to do is to go to column 2, then move down to the 9th row. Are you getting it? Move down to the 9th row, then you get 4.26. Are you getting what I'm saying? So now 4.26. So in this case now, if you compare it, the F calculated is 4.06, but the F tabulated is 4.26. And for us to reject it, that means our F calculated must be greater than F tabulated. Now, since our F tabulated is greater than F calculated, F tabulated is greater than F calculated. So that means we have to accept it. We can't reject it. Okay, let me look at the statement here. I'm still on page 42. It says since 4.06 less than 4.26, so that is F calculated less than F tabulated, we accept H naught and conclude that there is significant difference among them. So I hope you are following. So you accept it, that means there is significant difference among them. So that's what that one is implying. So I hope you take note of that. So let me quickly take you through the page again so you get what I'm really saying. Okay, look at page page 37. F calculated greater than F tabulated, we reject H naught. So there is the significant difference. So I hope you are taking note. So we reject it. So now since f calculated is less, so that means we have to do what? We have to accept it. So we have to accept it like that. So that's that. So I hope you take notes. In another video, we'll talk about how to get your f tabulated from your table of reference. Thanks for watching. Don't forget to share and subscribe. Bye.